Welcome to my YouTube channel. Dhanesh here. So in this video, I am going to discuss about stochastic gradient descent. See, gradient descent, it is one of the most important algorithms in machine learning and even in deep learning as well. See, deep learning, when we discuss about backpropagation algorithm, in neural networks, we use gradient descent. Even in artificial intelligence, see, gradient descent, it's one of the most important algorithms. See, first I will tell you an overall idea about gradient descent algorithm. See, gradient descent, it's a repetitive, iterative process for finding out the minimum of any mathematical function. So you need to understand. First, I am discussing about gradient descent. See, gradient descent is used to find out the minimum of a mathematical function. Any function. This gradient descent algorithm we use in economics, statistics, now in machine learning as well. So it is generally it is used to find out the minimum of a mathematical function. It is a repetitive, iterative process, and it is used to find out the minimum of a mathematical function. When it comes to machine learning, this is used to find out the minimum of cost function. The minimum of the cost function. Cost function, you may be familiar, cost function or error function or loss function or objective function, all these terms represents the same. This cost function, we use it in economics, even in statistics, the same way, gradient descent, and in machine learning as well. See, cost function denotes error. I can tell you cost function is equal to the predicted value minus the actual value, or target value minus predicted value. This is the simplest equation I can give you for cost function. Cost function is equal to predicted value of the machine learning model, what is predicted by the machine learning model, minus the actual value, the target value. This is the simplest equation, but the proper correct equation will be, I can give you the exact equation. Cost function is equal to 1 by 2 sigma I is equal to 1 to n. Then you can write it as y dash minus y the whole square. Here this 2 is the calculus factor. See, when you use the power rule, the derivative of x raised to n is n x raised to n minus 1. To avoid that n, or here it is 2, n is 2, so we are using this 2, the calculus factor. So why we are using the square, or you can use the modulus as well, because when you calculate the error can be positive or negative. So if it is both positive and negative, when you add it, you won't get the exact value. To avoid that, you use the square. Anyway, the gradient descent algorithm is used to find out the minimum of this cost function. See, when we see, there is a separate playlist in my YouTube channel. You can go through the videos, because I have given all the in detail. I have explained that algorithm, gradient descent. See, to find out the minimum of a function, there is the calculus approach is there. So you can find out, see, what is the minimum of a function. So this is what you need to understand. The minimum of a function means, for example, you have a function y is equal to x square. So this is a second degree equation. If this is the graph, then this is known as the global minimum. This is the minimum of the function. Even by using the calculus method, even I explained that method in that video, so you can see it. By using here, this video is mainly for the stochastic gradient descent, so you can just see it. If you want to learn more about gradient descent, you can watch the videos, the playlist gradient descent. So this is the global minimum of this function, this mathematical function. To find out the minimum, you have the calculus approach. But we can't use calculus approach all the time, because when the function becomes complex, to solve for x, see, we want to find out the value of x, for which value of x is, see here, if it is x is equal to 1 2, see the value, the minimum is happening at x is equal to 2, this value we are interested, this is the most important thing. So for to when the function is very complex, to solve for x it becomes very complex. That's why we come up with the gradient descent algorithm. So in this algorithm we will take a wrong value for x. See, we will assume that this is the point, this is the value of x at which the function becomes minimum. From there we will iterate. See, from there we will just move, like for example, if this is our function, we have taken a value x here, this is our value, this is wrong, then we will move, come, again increase the value, x is increasing, right? We change the value for x, and let's see, this value is, so like that we will iterate and check it whether the function is minimum, and again we will increment the value of x, and we will check it whether the function is minimum or not. So this is the method we use in gradient descent algorithm. For that we need to get the slope. Slope means the partial derivative. Slope, it is slope is dy by dx or tan theta. All these equations if you see a point here, the slope of this line, if you take, this is the tangent, makes the slope, means its definition is if the tangent makes with the positive direction of the x-axis. So this is the slope, tan theta. Here in this side slope is negative, and in this side, if you take the point here, this side the slope is positive. So from this you can understand, when here the slope is negative, here the slope becomes 0, and when the slope increases, becomes positive, you can trace that point. You are getting my point? See, tan of a obtuse angle is negative, tan of an acute angle is positive, the values. Tan 0 is 0, and tan 30 it is 1 by root 3, tan 45 it is root 3, sorry, tan 45 it is 1, and tan 60 it is root 3, all these things and when if it is tan 90 it is infinity, and if it is more than that it becomes negative. That change in the slope, that only we are using in this algorithm. This is really interesting actually. So anyway, if you want to understand these aspects, it's fine, you can learn it. But you want to understand these equations for gradient descent algorithm, we use for if it is x, the equation is x of I plus 1, the new value is equal to xi minus alpha into f dash x. So you can write it like this, f dash x, f dash of x. F dash means derivative, f dash of x. We'll write it properly. This is f dash of x. This is the equation we use for gradient descent to find out the value for for if the variable is x. But when it comes to, see, this is the new value, x of I plus 1 will be the old value minus alpha into f dash x. Here alpha is known as the learning rate. Its value changes from 0 to 1. So I told we need to iterate. It's a repetitive process. First you will take x as one value, then we will increment. See, at that time, what is the size of the baby step? What is the size of the baby step we are taking? That is known as the learning rate. It is the step length. Alpha, we can call it as the step length. How much it is the size of the baby step we are going to increase to find out the next value of xi, and we will see whether in that x the function is minimum or not. This is known as the alpha, the learning rate. Its value changes, it is in between 0 and 1. You can take any value between 0 and 1. That is the general equation. When it comes to the cost function, cost function, it depends on two variables. You can understand that cost function depends on two variables. Cost function depends on the weight of the network and the bias. So when it depends on multiple variables, we will go for partial derivative. You know that that is the calculus approach. So our cost function depends on two variables. One is the weight and the bias. So I will write you the equations for the weight and bias. So the weight, new weight, we can write it like this: weight of x of I plus 1 is equal to old weight wi minus alpha into dou of error or cost function divided by dou w. This is the dou denotes the partial derivative, and in the case of bias, b of I plus 1 is equal to bi minus alpha into dou of E by dou B. These are all the two most important equations for gradient descent. So by this method, we will calculate the minimum of the cost function by using these equations. But problem here, you need to understand, there may be billions or trillions of rows of data in real-time projects. When you take it, there should be trillions of rows of data will be there. So we will select if you want to do very fastly, what you will do is we will select one random data. We will select one random data and apply the gradient descent algorithm. You understood what I am telling? There may be billions of rows of data in our real-time projects. So at that time, what we can't do, we can't apply the gradient descent algorithm to all these rows of data. All these samples we cannot do. So what we will do, we will select one random data and apply the gradient descent algorithm to that and come up with the minimum of the cost function. This is known as the stochastic gradient descent approach. This we call it as the stochastic gradient descent. That's all. In real-time projects, you have millions or billions or trillions of data. At that time, you will select one row of data and select and apply the gradient descent algorithm. Then we call it as the stochastic gradient descent. Then it would be very fast. So we uses only one sample here. So this is the advantage, is it is very fast. This is the advantage. You can tell the stochastic gradient descent is very fast. At that time, we are using only one sample for this stochastic gradient descent. Now, if you apply all the millions of rows of data, then we call it as the regular gradient descent. It's very slow. You see, if we are doing the gradient descent algorithm to all these samples, then we call it as the regular gradient descent or batch. It is known as the regular gradient descent or batch. The advantage is it would be the most accurate. The accuracy is very high. The disadvantage here is it is very slow because we need to apply to all the rows of data. So this is the case. Now another approach we usually do, that is we will take, for example, we have n samples. Let us assume that we have n samples. In stochastic gradient descent, we will take one sample from this. In regular gradient descent or batch, we will take all the n samples. Next is the mini batch. we will call it as the mini batch gradient descent. Here we will take m samples, there m is greater than 1 and less than n. This is known as the mini batch. So these are all the commonly used, three types of gradient descent algorithms. One is the stochastic gradient descent, second one is the batch, and the third one is the mini batch. So this is the first one, this is the second one, this is the third one. So here in the stochastic gradient descent, we are using only one sample, and in the batch we are using all n samples. And in the mini batch, we are taking only m samples from the n sample, but this m is less than n and it is greater than 1. So this is all about stochastic gradient descent, batch gradient descent, and mini batch gradient descent. Thanks for watching.